All right, hi everyone. Today we are going to be talking about triangle mid-segments. And a mid-segment in a triangle, it's really just a line segment that kind of goes through the triangle. So just to show you a picture over here, so we have this triangle here, triangle ABC, so this outer triangle here, and then we have this line that kind of like cuts through it, right? This line DE. That line is called the mid-segment. And the reason why it's called the mid-segment specifically is because it connects the two midpoints of these sides over here. So the side AB and BC, if you take the midpoint of each of those sides and then you connect the dots, it creates this line which is called a mid-segment. And there's some special properties about that mid-segment, which we're going to talk about today. So a triangle mid-segment, it's just a segment that connects the midpoints of the two sides of the triangle. And in this example here, in the picture that we see, the mid-segment would be segment DE. Okay, now there's more than one mid-segment in each triangle, but for now we're just going to look at one at a time. All right, now there is a triangle mid-segment theorem that says a couple different things about some properties that'll be true in these triangles. And if you see this mid-segment here, so the DE, that line that we just talked about, that line is always going to be parallel to this bottom side here, that third side. And that's always going to be true as long as this thing is actually a mid-segment, which means it's connecting the two midpoints here. It's always going to end up being parallel to the side that's directly across from it. So that's the first thing we're going to say here. So if a segment joins the midpoints of two sides, then that segment will be parallel to the third side. And so I'm going to mark that on this picture here. We're going to put these little arrows. It's also going to be half as long as the third side. So for example, if this was 5, that means that this bottom side here would be 10. So this mid-segment, it's always going to be half of whatever this is, or you can think of it the opposite way. So if you have this mid-segment of 5, that length down here is always going to be twice as much as the mid-segment. So we'll write that here. It's going to be parallel to the third side. It's also going to be half as long. So a couple things we could say about that picture there. We could say that DE is parallel to AC. And we can also say that DE is going to be half of AC. Or you could think of that as the other way around. So you could think of it as AC would be twice as much as DE, 2 times DE. And we also have something called the mid-segment triangle. And this is another triangle that's created within the triangle. So as you can see here, we have this outside triangle, and then we have this interior triangle that's in the middle here. This triangle is created by connecting all of the mid-segments. So if you look at the picture here, so M to P, that is a mid-segment. We can tell that it's a mid-segment because it's creating these congruent parts here. So M has to be the midpoint since both of these pieces are equal. P has to be the midpoint since both of these pieces are equal. So that means this is a mid-segment. But we also have a mid-segment here. So NP, that's a mid-segment, and so is MN. So these are all mid-segments. And if you connect all of them, they create this little triangle in the middle. We're going to do more with that in a little bit. But for right now, let's just look at some examples of how we will use the mid-segment to find some missing pieces of triangles. So in this first one, it says DE is a mid-segment of triangle ABC. So that means this side right here is the mid-segment, and they want you to find the value of X. So remember that the mid-segment is always going to be half as much as whatever this side across from it is. So if you look at where the parallel sides are, those are the sides that kind of correspond with each other. So this length is always going to be half as much as this length. So if we want to know what X is, you just have to take half of 28, which is the same thing as just dividing 28 by 2. So that means X would equal 14. The next one is kind of the opposite, right? So they give you the mid-segment here, but this time we know what it is. It's equal to 15. So if 15 has to be half as much as that bottom side. So instead of taking half of 15, we're just going to take 15 and we're going to multiply it by 2. So that means X is 30. And then the third problem, it doesn't really involve the mid-segment. The mid-segment's here, right? So the mid-segment, remember, it connects midpoints. So these right here are midpoints. And this time they're not asking for like the length of the segment or the length of this side. They're asking for the length of this. And as long as we know that this is a midpoint, that means that the lengths of this piece and this piece have to be congruent. So if this is 9, that means X also has to be 9 because E is the midpoint. Okay, go ahead and turn the page. We're going to do some more examples. All right, in these first two examples here, they're just asking us to identify the parallel segments, and they kind of connected all these mid segments here. You have 3 different ones. So if you look at this one here, that mid segment is going to be parallel to this side. So we can label that one first. We'll say XY is parallel to QS. So that's one of them. And then we can do that same thing for the rest of them. So here's another mid segment. I'm just going to use blue for this one. That's going to be parallel to this side. So it's always going to be parallel to the side that is like across from it, right? So those are parallel. We can say XW is parallel to RS. And then finally we have this one here. So WY is going to be parallel to QR. All right, and for the sake of time, we're actually going to skip number 2 here, just because it's the same exact thing that we just did, so we don't really need to do that again. If you would like to try that on your own, you're more than welcome to. The answer key to these notes will be posted on Google Classroom, but we're going to go ahead and move on to example 3. It says that L, M, and N are midpoints of the sides. So that means that all of these little segments here, those are all mid segments because they're telling you that these points here, those points are the midpoints. So let's label the rest of this information that they give us. So PR is 46. That's from here to here. And then they tell us that PQ is 40. So this is 40. And LN is 17. So that's this right here. And then they're asking for all of this missing information. So let's take a look. First, they want to know LM. So LM is this segment right here. So if you kind of match that up with the side that it goes with. So LM is the mid segment, and it's parallel to this side at the bottom. So remember the relationship here is that this piece is always going to be half as much as this piece. So we can just take 46 and divide it by 2. And that would give us what LM is supposed to be equal to. So that would be 23. All right, so that is LM. And now let's take a look at the next one. So the next one says MN. So if I look at MN, that's this mid segment here. And we're going to use that same relationship. This mid segment is parallel to this side of the triangle, which is equal to 40. So if I take half of 40, that should be my mid segment, right? Half of 40 is 20. So MN would be 20. All right, and then QR. So QR goes from here to here. And this one is a little different. So this time they're asking for the side of the triangle. So, and we can't really figure it out. Based on these other sides, we can't use those to figure it out. So we're going to have to use the mid segment to figure it out. So this mid segment is 17. And remember, this is always half. So if I want to figure out the side, I would just double it. So 17 times 2. So that would give us 34. All right, and then the last piece that they want is MR. So let's go ahead and figure that out. MR is this piece right here. Now remember, we just figured out that QR is 34, and because this is a midpoint, that means each of these pieces would be 17 because half of 34 is 17. So that's what MR would have to be. Okay, so let's take a look at this next one here. So once again, they're telling us that F, G, and H, these are all midpoints, right? Which means these segments in the middle of the triangle, those are the mid segments. So let's label the information they give us. FG is equal to 9, so that would be this mid segment here. GH is equal to 7, and CD is 24. That's this whole side here, 24. Okay, so let's try to figure out the missing pieces here. So the first thing they're asking for is CE, which is this side of the triangle. So you wanna try to find a mid segment that's parallel to that. That would be this one. And if you take 7 and double it, that would equal the side, right? So 7 times 2 is 14. So that one's all done. And let's take a look now. Oops, I didn't want to erase that. Let's take a look now at the next one that they want. So the next one they want is DE. That's this side. So I want to try to find the mid segment that's parallel to that, and that would be this one here. So we're going to take 9 and we're going to double it, right? Because the mid segment's always half of whatever this is. So we'll do 9 times 2, which is 18. All right. So that's, oops, this is 9, this is 7. Okay, so FH is this mid segment here, and this time we would have to use the fact that the whole side is 24. So we're going to take half of 24. So that would be 12. And now they want the perimeter. So remember, perimeter means to add up all the outsides. So we kind of want to make sure we have all the outsides, right? We know that one side is 24. We just need these other two sides. We do know that this side, DE, we found it already, right? We said it was 18. And we found CE already also. That was just 14. So they want the perimeter of CDE, which is this outer triangle here, CDE. So you would just have to add all those up. 24 plus 18 plus 14. And that would give us 56. Okay, so let's take a look at some problems that involve a little bit of algebra. So number 5 says find DE. So let's take a look at what we have here. So they're giving us, this is a mid-segment. I know it's a mid-segment because of the way they marked the picture, right? This is a midpoint because these two are congruent. This is a midpoint because these two are congruent. So I know that this is a mid-segment. And the way that you would set this up, so remember the relationship. We know that this one is always half of whatever that is. Or an easier way to think of it would be to think of the bigger one. Think of this as 2 times the smaller one, right? Like 2 times the smaller one. If you wanted to make an equation that said that, we could say, okay, 2 times the smaller one, which is 4x plus 1, has to equal the bigger one. So we'll put 11x minus 25. This is how I would normally set these up. I would do 2 times the mid-segment equals that bigger side. And then once you have this equation here, you can just solve this. And we'll have to distribute in order to solve this, right? So this would become 8x plus 2 equals 11x minus 25. And then you can rearrange this however you normally would. Once you move the 8x over here and the 25 over here, you're going to end up with 3x equals 27. And then you can divide by 3, and you'll get x equals 9. But that's not what they want, right? They want DE. So you're just going to have to plug it in. DE is right here. You're just going to have to plug it into that 4x plus 1. So 4 times 9 plus 1. That's going to give us 37. So that would be our final answer. DE is 37. All right, let's take a look at number 6. So number 6 is asking for a lot of different angles here. So we haven't really done anything with angles yet with these problems. So let's try to figure out how we're going to do this. Okay, and the way that I like to do these problems, typically these problems that are asking for like a lot of information, I don't always find them in the order that they're asking for it, if that makes sense. Like you don't have to start with angle 1 if you don't want to. What I like to do is just look at the picture, and I like to just try to fill in the picture. It's kind of like filling in a puzzle, right? Like we've done a lot of problems like this where it's kind of like figuring out pieces to a puzzle. So let's just start with what we have and see what we can do here. One thing that I notice right away is that these two angles are right next to each other on a straight line. And remember, we learned about what that is a long time ago. Straight lines always equal 180. So if I wanted to figure out angle 2, I could just do 180 minus 127, and that would give me the measure of angle 2, which is 53. So I know that angle 2 is 53. I'm going to go ahead and label that on my picture here. So angle 2 is 53. Okay, so let's see what else we can do. So usually when you have mid segments, this is a mid segment, you're gonna have to use parallel line relationships, which we haven't done these in a long time, but we do know that those lines are parallel, and you have a couple transversals here. So again, I know we haven't talked about these in a while, but if I draw a line like this, we have lots of different angle relationships that we could figure out. So one thing that we can say is that this angle and this angle, those are congruent because they are corresponding angles. So I know that angle 1 also has to be 53, right? So that's one piece of information we could use. We also have a different transversal over here. If you look at this side, right? And I have another set of corresponding angles. This angle and this angle, those are corresponding. That means angle 4 has to be 59. And then we're kind of getting into an area now where we could do a lot of different things. So I'm going to clean up some of these markings here just so I can see what I have left. So I know angle 4 is 59. If you look at this, we have another straight line, right? Like this is a linear pair. These two angles make a linear pair. So I could do 180 minus 59, and that would give me the measure of angle 5. So if you subtract those, you're going to get 121. So the measure of angle 5 is 121. And the only angle that we're missing now is angle 3. That's the only one we need to find. And what I would do, some of you have probably already realized this, you have a triangle right here. Like, I'm going to shade it in so you can see what I'm talking about. This right here, that's a triangle. And with triangles, remember, they always add up to 180. All the angles add up to 180. So you could take 53 and 59, and you could just subtract those from 180, right? You could add them together and then subtract them from 180. And once you do that, you are going to get 68. So that would be the measure of angle 3. And we've filled in all the angles. We just need to list them out over here now. So let's see, the measure of angle 1, we know that that's 53. So is angle 2, right? Angle 3, that's the one we just found. That one was 68. Angle 4 is 59. And again, I'm getting all these numbers from my picture over here because I labeled my picture. And then angle 5 was 121. And that's it. So this is kind of how I would recommend doing problems like this. I would just start filling in your picture instead of trying to find them in the order that they list them, because sometimes the order that they list them doesn't always make sense. I would just fill in the picture and then fill in all your answers afterward. Okay, so let's take a look at problem number 7. All these problems are very different. I wanted to give you a good variety of stuff that you might see. So if we look at number 7, this time they're telling us that these are all mid-segments. So all these segments in here, those are all mid-segments. And we're supposed to find the perimeter of JKL, which means we need to find the outside of this triangle. So this one requires a little bit of work. So let's see. We first need to figure out what X is, right? Because in order to find the perimeter, I kind of need to know what X is eventually. So let's see if we can make an equation. I know that this side is parallel to this mid segment. So remember, if I take 2 of these, that's going to be equal to the bigger side. So I want to do 2 times the mid segment, which is 6x minus 1, and set that equal to 13x minus 10. And then I'm just going to go ahead and quickly solve this. I know that we know how to solve equations like this already, so I'm not going to do this super slow. I'm just going to distribute 12x minus 2 equals 13x minus 10. And then once we move this over here, we're going to get just 1x, x minus 10 equals negative 2, and then we can add the 10, and we'll get x equals 8. Okay, so we've just solved for x, and now we need to plug it back in because we need to figure out what some of this stuff is equal to, right? So I can plug it back into this side to get the length of this side here. So 13 times 8 minus 10, that's gonna, when you plug all that in, that's gonna equal 94. Now the other sides, you can actually go ahead and get those right now. So we can use these mid segments here, so like 49. If I double that, that's going to be equal to this side that's across from it. So 49 times 2, that would give me 98. And then I only need one more side now. So if I take 42, that one is parallel to this side. So if I take 42 and I double that, 42 times 2 is 84. So that's my third side over there. And now I have all three sides. So they want the perimeter, which means I would just add up all three of those sides. So the perimeter of JKL would just be 84 plus 94 plus 98, which gives us 276. Okay, so that's how you do the perimeter problem. And then we have two more problems here, and these ones involve a little bit of algebra. So let's take a look at number 8. So number 8, it's asking us to find the measure of an angle, measure of angle CBF. CBF would be this corner angle right here. So if I knew what x was equal to, then we could figure that out, right? Now remember, we have parallel lines because that's a mid-segment, and we have a transversal here, which means these are corresponding angles. Those have to be congruent. So we're going to set these two angles equal to each other. So we can say 9x plus 2 equals 15x minus 52. And then we'll just go ahead and rearrange this and solve this equation. Once you move stuff around, you're going to end up with 6x on one side and 54 on the other, which means x is going to equal 9. And then to get the angle that they wanted, you would just take that and plug it back in. So 9 times 9 plus 2, that would give us 83. So 83 degrees, that would be the measure of angle CBF, 83 degrees. All right, and then last one on this page, number 9. This one also is dealing with angles, but they're a different pair of angles. So if you look at the mid segment and the line that it's parallel to, so here's our parallel lines, and then this would be our transversal that we're going to use. This time they're giving us these angles here. And I know it's been a long time since we talked about this, but these angles will actually not be congruent. Remember, in parallel lines and transversals, these are called same side interior. Same side interior, and they're not congruent. They actually equal 180. So that's something we learned a long time ago, but they will add up to 180. So instead of setting these equal to each other, we're going to add them together and make it equal 180. So we can say 6x plus 1 plus x plus 4 equals 180. And then we'll just go ahead and solve this. When we combine our like terms here, we're going to get 7x plus 5 equals 180. And then we can subtract. We get 7x equals 175. And then once you divide, you're going to get 25 for x. And let's see what they want us to find. They want the measure of angle RTV. RTV, if you trace that, that's actually this corner angle here in the bottom. So that one's really easy to plug in for, right? That would just be 25 plus 4, which is 29 degrees. So that would be the answer for number 9. All right, and the last thing we're going to learn how to do is how to deal with mid-segments in the coordinate plane. So we're just going to do a couple examples of this. Sometimes you will be asked to kind of prove that something is a mid-segment, and it's actually pretty simple if we use things that we already know. about slope and distance and stuff like that. We've done stuff like this before. So if you look at what that example is asking, it says, in triangle JKL, show that the mid-segment MN is parallel to JL and that MM equals half of JL. So they're kind of asking us to prove basically that this is actually a mid-segment. And in order to show that information, we have to do two things. We have to first of all prove that these lines are actually parallel, and then we also have to make sure that this is equal to half the amount of this one, okay? So it's actually not bad. We're gonna go ahead and do that. So first, we're gonna use slopes, right? That's how you show that lines are parallel. So if I find the slope of this line and the slope of this line, they're supposed to be the same slope in order to be parallel. Now you can find slope a bunch of different ways. Some of you prefer to just do like rise over run. I'm finding that a lot of you are messing that up though, and I don't really know why, but a lot of you are not calculating slope correctly when you count rise over run. So if you want to, you can just use slope formula, right? Like you can write out your coordinates. So the coordinate of M would be, what is that? -4, +3. And the coordinate of N would be 0, 2. And we can just use those coordinates to find slope, right? So I'm going to go over here. Let's find the slope of MN first. And when you do slope, it's just y2 minus y1 over x2 minus x1. So let's do MN. That would be, I'm going to use this one as my x2, y2. So that would be 2 minus 3 over 0 minus -4, which would give us -1 on the top, +4 on the bottom, because you got this double negative going on here, which means our slope of MN is -1/4. That's the slope of MN. So I just did that with slope formula. Now I do want to mention, like I said before, you don't have to use slope formula if you know how to find slope just by counting. So if you look at the points here, this is going down 1/4. That's -1/4, right? So like if you know how to do that, you can do it that way. Sometimes you might not have a graph though, or maybe the graph might be really hard to read. So it is a good idea to use slope formula just to double check. So slope is -1/4. So let's find the slope of the other one. So we're going to find the slope of this line because those are supposed to be parallel. So, and they actually gave us the coordinates for those, right? So we can just use those two coordinates. So the slope of JL, let's see, it would be -1 minus 1 over 2 minus -6, which would give us -2 on the top. This is like 2 plus 6, right? Which is 8. And that does reduce to -1/4. So we've just shown that the lines are parallel. And that's all that we have to show, right? We just have to make sure that the slopes are exactly the same. And this right here, this is the work that I would need to see if you were doing this problem like on a test or something. I would need to see this work, or I would need to see you doing your work on your graph if you're finding slope from a graph. I would just need to see that you did the work. Okay, step 2. So what we've just done, we've done this part here where it said, show that the mid-segment's parallel. That's what we've just done. Now they're asking us to show that this is true. So I want to show that the mid-segment is half of that bigger side. And to do that, we just use distance formula. So we're going to find the distance between those sides. So, or between those points. So let's take a look at our triangle here. So once again, I'm going to need the coordinates of the mid-segment. This one was 0, 2. This one was -4, +3. And you can do distance formula however you want. We've done it over and over and over again. So the big distance formula, if you're a formula person, it looks like this. x2 minus x1 squared plus y2 minus y1 squared. So that's the distance formula. Now, I've talked about this a million times, and you guys know that I don't typically use this formula. I find little shortcuts to help me figure it out. I do like the thing where I make a triangle out of this, and then I kind of do Pythagorean theorem. But you guys can do this however you want to. So I know that a lot of you like to use the whole formula, so I'm gonna go ahead and do it that way. So if you look at the coordinates, I'm going to start by finding the distance of MN. Let's start with that one, MN, which is the shorter one, the mid-segment. And I have the coordinates already listed up there, so let's just label them. We'll say this one's x1, y1, this one's x2, y2, and then we're just going to use a distance formula, right? So let's go ahead and do that. In the first set of parentheses would be my x values. So if I start with x2, that would be 0 minus -4 squared. And then if I put my y values in there, that would be 2 minus 3 squared. And let's go ahead and figure out the math here. So 0 minus -4, that would turn into 0 plus 4, right? Which would be +4. So this is 4 squared plus -1 squared, which would be the square root of 16 plus 1, which is the square root of 17. And if you put that in a calculator, the square root of 17 is approximately 4.1 if you round. Okay, so that's the distance of MN. And now we're going to do the same thing, except we're going to find the distance of JL. And we're going to try to see if that relationship holds true. So let's go ahead and do that. So same exact thing. We have the coordinates for JL. So that's what I'm going to use. This one will be our x1, y1. x2, y2, and then let's go ahead and figure it out. By the way, I always have people ask, like, does it matter which one you do, x2 or x1? It doesn't matter at all, right? So you could have started with this one if you wanted to. It doesn't matter, as long as you're consistent. Okay, so distance formula for JL, that would look like 2 minus -6 squared. Oops. Plus -1 minus 1 squared. Okay, and let's simplify a little bit. This would become +8 squared plus -2 squared, which would give us 64 plus 4, which is the square root of 68. And if you go ahead and put that into your calculator, the square root of 68 is approximately 8.2. And you can see that that relationship is true, right? If you take 4.1 and you double it, 2 times 4.1 equals 8.2. So this works out. Everything is exactly what we thought it would be, right? So they said show that MN equals half of JL. We've just shown that that's true. 4.1 is half of 8.2. So that's all set. That's how you do this. So, and I know that it's a lot of work. Remember, you don't always have to do all of this work. There are shorter ways to do distance formula. I've talked about them many times. You guys can use the little right triangle thing with Pythagorean theorem. You can take shortcuts when you do your subtraction stuff here. So just find a way that works for you. But that's all we're doing here. We're just finding slopes to show that the slopes are the same. And then you're finding the distances to show that this is half of the bigger distance. Okay, so again, for the sake of time, we're actually going to go ahead and skip that you try problem. You can do it if you want to. I will post the answers to this note packet online so that you can check your answers. But we're going to just go ahead and pass out the work for today so you guys can get started.